Good morning, all of you. So, we are entering into the third unit of our syllabus. In third unit, we'll begin with correlation. What is meant by correlation and why correlation is very important for our study with respect to data science. So, in this lecture, I'll give you an introduction. I'll give you an introduction to what is meant by correlation, what is positive, negative correlation, what does it mean when I say there is no correlation between two variables. We'll see some basic formula, correlation coefficients, how to find out correlation coefficients, and then we'll be seeing scatter plots. And in the coming session, possibly, I will be explaining to you matplotlib.py plot library in Python, where you will be plotting graphs. Okay. Similarly, we have a very interesting library called as pandas, where we'll be interacting with a Excel sheet. We'll take a Excel sheet and we'll work with Python and we'll interact. We'll draw the graphs. We'll find out the correlation between different variables and so on. Right. So for visualizing, we'll be using matplotlib. We have one more interesting library called as Seaborn. Okay, so if time permits, that's beyond the scope of our study. Basically, may not appear for your exams, but still, it's a very interesting part of Python. Why Python is highly used in data science applications. So once you learn the Seaborn, you will be. This might help you for your interviews. Although it is not there in your prescribed syllabus, it's a very interesting and a very basic, important topic that you may need to know if you would like to work as a data scientist or a data analyst. Okay. So if time permits, we'll go deep into the other libraries and packages available in Python. But as of now, we'll concentrate on finishing or as of now, we'll concentrate on studying the basic skeleton of our syllabus. Okay, so visualization, data visualization, we have a very important library, matplotlib, that is a basic library that is compulsory, that is there in your syllabus. You need to study that. You have questions, you have a lab, you have practicals and everything with respect to matplotlib. Seaborn also, we have some experiments in the lab, but in theory, we are not going to concentrate much on that. It is, of course, an additional learning, not actually an additional learning. In today's, we are drafting our new syllabus for the next year, next regulation. Now we are coming under regulation 2024. Regulation 2026, the syllabus will be changed, and in that syllabus, we'll be including Seaborn also. Right? It's a data visualization package. It is built upon matplotlib. Okay. So matplotlib is the foundation. For that, we are building additional packages. Okay. So we'll learn the patterns and so on. We'll find the strength of correlation. We'll find different ways of finding correlation coefficients. Okay. That will be explained to you in the coming slides. So let's begin with the definition of correlation. Correlation is a measure of linear relationship or association between two continuous variables. We have an independent variable x and we have a dependent variable y. Okay. Now, correlation means what is that relationship between this x and this y? If x increases, y will increase or not. Okay. Say for example, let us consider x to be a variable, something like the number of cigarette a person smokes a day, and y the probability of the person getting cancer. Okay. So as x increases, y also increases. So what is a correlation? To what extent will x influence y? Okay. To what extent will x influence y? It can be in the positive side, it can be in the negative side. Positive side means as x increases, y increases. Negative side means as x increases, y would decrease. Okay. So here, uh, usually x is plotted in this and y is plotted in this direction. Okay. Very common, as usual, we'll draw our graph, no? X-axis and y-axis. So correlation means the relationship between two variables, how far an independent variable is going to influence an dependent variable x, y, to what extent it is going to influence, and what is a direct relationship. This means that if it is a positive correlation, when x increases, y increases, but if it is a negative correlation, when x increases, y decreases. If there is no correlation, whatever happens to x, y does not get changed at all. Am I clear so far? Have you all understood the concept of correlation? You might have already studied this in your basic statistics classes, but this is something that we are going to go slightly in depth. I will be teaching you Python programs to calculate the correlation coefficient very easily. Okay, in the coming classes, in the practical classes, I'll be giving you a real example and I'll be asking you to do some programs wherein you will be really understanding what is this correlation all about and how simple, easy, and interesting Python is to find out all these complex calculations. Okay, to be very frank, I forgot all the formulas which I studied in statistics because everything is being done in Python. Okay, so you will also start doing it, but it is an academic requirement as well as I also feel that you should know how to do it manually. Only then you can do it using Python. But once you start getting used to Python, you forget what happens manually. That's natural. But you should be well aware of how to calculate things manually also. So, as I told you, when x increases, y increases. That means x is proportional to y. If x is the number of hours you are studying for a subject or studying for your course or your program, y is the result. As you study more number of hours, your results should naturally get increased. Okay. Car age versus its resale value, another example for negative correlation. So as the age of the car increases, the resale value is going to decrease, right? This is one example. Second-hand cars, you are selling it. The older the car is, the lower the price is. So this is a negative correlation. Negative correlation, that means x is inversely proportional to y. That means if x is increasing, y is decreasing. As x increases, y decreases. And next, obviously, zero correlation. Zero correlation. I used to give some examples. The attendance of a student and his mark. Not every teacher is going to agree with me, but it is not compulsory that every student has to attend every day so that he gets good marks. Okay, but the number of study hours is proportional. Okay, or the dress you wear compared with the marks you score. There is no relationship at all. Whatever dress you wear, you score good marks. Okay, is that clear? That means that whatever happens to x, there is no connection between x and y. Okay. So, zero correlation, there is no relationship between both these x and y. X is totally not connected with y. Okay. So this is an example. I've shown you the graph also. You can see that the graph is going to indicate that when x is increasing, y is also gradually increasing. 8 hours you study, you are able to score 90 marks. As you decrease the study hours, your marks are proportionately decreasing. The students who study more number of hours tend to score higher marks in exams. This is a simple example to show positive correlation between two variables. One variable x, I have taken it as study hours. Another variable y is a mark you score out of 100, say for example. So next is about negative correlation. As x increases, y is decreasing. Age of a car and its resale value. I put this arbitrary values. Maybe you can add zeros in the end. Okay. So a new car have a higher value, less than 1 year, 25,000, 1 year, 22,000, and 2 years old, 19,000, 3 years, 4 years, 5 years. As you go, as the years increases, this value is decreasing. Okay. So can you give me certain functions where x is increasing and y is decreasing? When I was talking to you about deep learning concepts, I was telling you about functions, no, sigmoid function and all. Okay, ReLU, activation functions and all. Do you remember that? Okay. Say if x is equal to 1 by y, x is equal to 1 by y, for example, is a negative correlation function. As the x increases, y naturally tends to decrease. Or sorry, y is equal to 1 by x, or x is equal to, actually put it the other way around, y is equal to 1 by x, because x is the independent variable. An independent variable is a variable where you collect the raw data. For example, the age of the car. Okay, it's an independent value. Dependent means is a value that is dependent on the independent variable, right? Okay. For example, most of you have applied for education loan, right? In the bank. Your annual family annual income and the amount of money sanctioned to you as education loan, is there any relation correlationship? Can you do it as a project? What is the relationship between the annual income of a family and the amount of loan that the bank sanctions to that family or somebody who has applied for that? Obviously, as family income increases, the banks will be more happy to give you more loans, right? So it should positively be a positive correlation. More the amount of income you have, the more you are rich, more people are ready to pay loan to you because they are confident of getting that repaid. Okay. Same way we might have so much in finance, you have, if you go to the world of banking and finance, you have so much of examples and so much of, what do you say, so much of scope for a data scientist to work on. Okay. So that will help you a lot. And most of the banks are now hiring data analysts, even to sanction credit cards, okay, and so on, right? I mean, there is a rating called a CIBIL score. You know that? How many of you have heard of CIBIL scores? Please raise your hands. One, two. Raise your hands so that I can really count out. What is a CIBIL score? You don't know, others don't know? Okay, we'll find it out. How many of you know your CIBIL score? There is one beauty in CIBIL score. A person who has not at all taken loan will have a very low CIBIL score. A person who has taken loan and repaid it correctly will have a higher CIBIL score. If you don't want loan, your CIBIL score is low actually, if you have not all taken a loan. If you have taken loan and you have repaid in time, your CIBIL score will increase. If you have not repaid, your CIBIL score will keep decreasing. Okay. So maybe we can conduct another one lecture on what is CIBIL score, how CIBIL scores are calculated and so on. Okay, but that will not be a part of our data science course because we may not have enough time for that. Okay, wow, that's an interesting one. What is meant by scatter plot? Very simple. We have two quantitative variables usually, x and y, x in the horizontal axis and y in the vertical axis. So this is a scatter plot. This is y, this is x. This kind of scatter plot shows there is no correlation between x and y. Okay. So there is infinite instances where we need to plot scatter plots so that we can understand the type of correlation between two different interesting variables. X independent, dependent outcome. Say X can be your CIBIL score and Y can be the probability that loan is sanctioned to you. We will be working on uncertainties. Okay. So we are very much interested in probability. Every data scientist have to work a lot on probability because probability is numerical, probability lies between 0 and 1 and so on. So instead of giving yes or no, we make it out into a probability, right? Instead of x and y, let us consider x to be the CIBIL score and y to be whether this person will get the loan or not. So instead of using yes or no, what we can do is that we convert this yes no into a quantitative value, that is the probability of yes and probability of y no. Okay, we would love to work when it is numbers because we get a certain value. We convert all our uncertainties into numbers. That is why probability is very important. That's why you should always keep your mind fresh with all the probability that you have studied in maths, engineering, maths, and other related subjects. As I was telling you in Regulation 26, I've included a separate paper exclusively for probability and statistics because of its application in machine learning, data science, and so on. So it's a very important, we can't avoid it. It's important, it is necessary. Okay. So probability and statistics is the core strength of a data scientist. So I believe all of you understood what is a scatter plot. And all of you understood how to write in an exam when a question is asked on what is a scatter plot. So before computing any kind of correlation, I always would like you people to give some small scatter plot. Like the study hours goes up, you know that it's a positive correlation. Car, the age, it goes like this down, so negative correlation. If it is scattered here, there, some other places, there is no correlation at all. Okay. So we have two types, linear and non-linear. Okay. In case of, see what is Pearson correlation coefficient, I will be teaching you in the coming slides. When I say that x is related to y, whether it is positive or negative, I need to quantify it, right? To what extent it is. I want to make it as an equation. I want to give numbers to it. So that number, to what extent the variable x is related to y, is called as correlation coefficient. Okay, so here when it is linear, it might be better. When it is non-linear, that means you have a curve. Okay, in that case, you may not be able to really find out with Pearson coefficient. Okay, that's just a point I mentioned. I will be teaching you how to find out the Pearson's coefficient and everything in the coming slides itself and this lecture itself. So the value of R or the Pearson coefficient is between 0 and minus 1. So if the modulus of R is 1, it shows that there is a strong correlation between the variables x and y. Okay, if R is equal to 1, even if there is a slight increase in x, y increases proportionately. Okay, when modulus of R is zero point 0.5, it indicates that there is some trend, there is some change. As x increases, naturally y also increases, but to a smaller extent. When the correlation coefficient is 0, it simply means that the correlation is very weak. Next important, those who are unable to make notes, the video will be posted and you can use that to make notes. Don't worry about that. So I told you now, we have understood that there is a relationship between two variables. We need to know, we need to quantify to what extent is that relationship. For that, the most important thing is Pearson correlation coefficient, denoted by R, or in some textbooks you find it as rho, for simplicity and easy of understanding. When you see Greek symbols, sometimes we get vexed. So I prefer R with that. R is the value of linear relationship between two quantitative variables. So when it is non-linear, that means that, can you give me examples of non-linear functions, or what is a linear and non-linear functions? What is a homogeneous function? These things are expected from you. These are prerequisites for the course. We really expect that you know all these things prior to you come for this course. What is a linear function? What is a non-linear function? Please go through and refer your basic mathematics so that you are more comfortable with. Okay, so there are technical ways of finding whether a function is linear or not, but now for easy simple understanding, I'll tell you that a function has to be homogeneous. If it is a straight line, it's always a linear function. When you have variations, no, it's non-linear. Mathematically, you have two conditions. One is should be a homogeneous function. The other one is f of alpha a plus b is equal to f alpha f of a plus alpha f of b. This is a condition for a homogeneous linear function, but that's out of the scope of this lecture actually. I'm not going to go in depth about that. That's something that you have to be ready with your magnets. Okay. So when R or the Pearson's coefficient is negative, it shows that it's a negative correlation. If it is positive, it shows that as x increases, y increases. Okay. So the magnitude increases that we have seen in the previous slide also. As the magnitude of R increases, it shows that there is a strong correlation. If it is minus 1, what it means? It's a strong negative correlation. That means if there is a slight increase in x, that slight increase is also reflected in, slight decrease is reflected in y. If Pearson's coefficient is minus 1. Okay. So plus or minus 1, perfect linear relationship. If R is 0, there is no correlation between these variables. If R is 0, there is no correlation between these variables. Okay. So we have seen the simple tabular form to explain more detail, but there is some problem when I created this. Okay. So when the modulus there is a weak, as R tends to 0, what it means is that there is less correlation, and as R tends to 1, that is modulus of R tends to 1, this shows that there is a very strong correlation. So as an example, I've taken some numbers and basically I've just tabulated it for your easy understanding. So all said and done, we know that R is what and everything. Now we are getting into the real implementation part of how should we find out R. Okay, is one way of finding out is the average of the product of paired z score, that is z score for each value. You are multiplying that and dividing it by the total number of values. Is one way of doing it. Okay, x and y are both above their mean. So you get for each value, right? For each value, you find out the z score and you multiply both the z scores and divide by the total number of observations. One simple way of finding out Pearson's correlation coefficient. So we know that R is positive when the pairs deviate in the same direction and negative when they deviate in the opposite direction. It's a very simple way, but there are much other methods which you need to study. So the real way or the computational method where you can find the Pearson's coefficient is like this: n sigma xy minus sigma x sigma y by root of n into sigma x square minus sigma x the whole square into n into sigma y square minus sigma y the whole square. This is the formula with which you shall calculate the Pearson's coefficient. I think this formula is simple, straight, and direct, very easily understood by all of you. We'll do some examples. We'll also learn how to do these with Python. Okay. All these things we will not be doing manually. All these things we'll be doing using Python. I'll give you or I'll teach you how to write Python code for each of these. But in your theory exams, you may face questions where you have to do it manually. There is no other solution for that. Okay. We'll have practical exams also. In practical exams, you will be given questions to find out Pearson's coefficient using Python program. But in theory questions, what you're supposed to do is that you have to solve these questions manually. So I've told you how to calculate, right? With the same example which I have taken before. So X is the number of study hours, Y is your marks. So what is X square? I've calculated the X square in the table, right? You can put it down here, 1 square here, 2 square, 3 square, and so on. Y square, similarly 55 square, 60 square, 65 square, 70 square, and so on. Then X into Y, 1 into 55, 2 into 60, 3 into 65, 4 into 70, 5 into 75, 6 into 80, 7 into 85, and 8 into 90, 720. So I get these values. So this is sigma x, this is sigma y, this is sigma x squared, this is sigma y squared, this is sigma xy. I request you to please make a note of all these things, otherwise you cannot do it. So now n, I've taken it as 8 values. Sigma x is 36, sigma y is 580, sigma x square is 204, sigma y square is 43100, 43,100, sigma xy is 2820. So n sigma xy minus sigma x into sigma y by root of n into sigma x square, that is 204, minus sigma x, that is 36 the whole square, into 8 into sigma y square, that is 43100, minus sigma y the whole square, 580. If you compute that, you will get 22,560 minus 2880 by square root of 1632 minus 1296 minus this one. So you get 1680 divided by root of 336 into 8,400. Then what we do? We get it as 1680 by 1680, which is 1. So what does this indicate? What is the meaning of this Pearson's coefficient R? When R is equal to 1, what it means? It means that the very strong correlation. The more you study, the more you get. Okay? The more time you spend on your course, the more you get the result. Okay? That's what we study for this. So now, Take this chart and find the correlation coefficient. What is R for this? So how many of you got -1? R is equal to -1. What is sigma x square? Sigma x square 55. Sigma xy 21. Okay. Sigma y square 195. Ah, okay. Sigma x, sigma y 58. 15, right. Sigma y 105. And when you apply it in this formula, you will get R is equal to -1. So what this indicates? Strong negative correlation. Okay. So I believe that all of you are very clear with what is Pearson's coefficient and how to find it out. Is there any clarification that you want? Any doubts? So Pearson's coefficient, we have one of the drawbacks, big drawbacks is that it is highly sensitive to outliers. Do you remember what is outliner? Extreme values or values that do not match the trend. Whatever you have a list of values. Say, if the marks of a student, I'm putting it as a data set, I'm getting only one student getting 100 out of 100 balance. The second mark is only 70 or something like that. So 100 can be considered as an outliner, or the values that do not fall in the proper range, or the things that tend to go beyond the limits. So in our previous classes, we have discussed what is outliners in detail. So one of the major drawbacks that we find when we work with Pearson's correlation coefficients is that it is highly sensitive to outliers. Okay, you can check it out with the data that is provided, or you can create a sample data with an outliner and you can see the difference with and without. outliners. Okay, so what happens is simply it increases the correlation or sometimes it reduces the, when you say it is inflation, it means that when you say it is inflation, it means that it is increasing, and when it is so one of the major problems that we face with Pearson's coefficient is that it is it is highly sensitive to outliers because it you are squaring the deviations from the mean, right? We have seen that mean is also highly sensitive to outliers. So what we have done, we have tried out with median because median is not very sensitive to outliers. You know why? In median, what you're doing is that you're sorting it in an ascending order and you're selecting the center value. In mean, what you're doing is that you are summing up all the values and dividing it by the number of observations. Okay. In median, what you're doing is that in the data set, you are putting all these things in ascending order and you are working with the central value. Okay. So it is always better that, so just with Pearson's coefficient alone, you cannot really come into a conclusion about its the relationship between these two variables. That's one drawback. Okay. So what we'll do is we usually draw a scatter plot before we do that. So if the original data has a weak correlation, if you add an outliner, the correlation might become very high. Okay. This is a natural trend. So outliners, what happens is that outliners can make the correlation appear to be much stronger than they actually are. Okay. So this is a misleading data, and so you may end up in a trouble when you really expect a correlation to be. I mean, our previous principal, no, he has given some correlation uh, assignments to us. It was very interesting actually. So correlation is something that you need to use in your real time environments. Absenteeism and scores. Okay. So there are so many variables that you can use. And this is the data that we really use to impact our machine learning models. So this is about inflating correlation. An outliner has increased this, and similarly you have an outliner that is deflating. You have an outliner sometimes something like this, so it can actually hide the strong relationship, or it can show that the relationship is not that good in spite of the fact that the relationship is very strong. Okay, except for one or two particular values. So what happens in deflating and inflating outliners? How inflating outliners affect the Pearson's correlation coefficient? So what happens here? We have some other alternatives. Not all data meets Pearson's requirements. So we need to have some say interval based cut. You know that We have nominal data, interval, ratio scale, and ordinal data, etc. So if a data is continuous, if data has linear pattern, we can, and if it is strongly between interval and ratio, you can really use Pearson's, but not in all other ways. Okay, so we have other alternatives to Pearson's correlation. We have Spearman rank correlation, point biserial correlation, phi coefficient, etc. But in our syllabus, we'll be concentrating more only on Pearson's correlation coefficients. So we need to choose right coefficient based upon the data type and its relationship. We'll just understand what is meant by Spearman's rank correlation also. So Spearman's rank correlation, like Pearson's itself, measures the strength and direction of monotonic relationship between two ranked or ordinal variables. So if the data is ranked, the relationship is monotonic but not necessarily linear. Data does not meet Pearson's assumptions. One second. So if Pearson's coefficient is really misleading, we go with Spearman rank correlation also. It's an alternative, but we don't need to do with this in detail, I believe. Similarly, we have other kinds of coefficients like phi coefficient, point biserial correlation, etc. So it's better for continuous variables, dichotomous variables, etc. Okay. So all these things are just for your information only. Sometimes you may be asked to explain. Sometimes you may be asked to explain different types of correlation coefficients. So we have point biserial correlation coefficient, phi coefficient, etc. These formulas and problems you don't need to remember for your exams, but you need to know what are the correlations. Sometimes you may be asked an overview of all the correlation coefficients. Okay, but you don't need to expect any kind of problems based on that. But Pearson's coefficient is almost sure you will have at least one question based on that. Clear? So now we look into the basics of Python programming with respect to drawing graphs. I prefer that I can give you an introduction to what matplotlib is and how to draw scatter plots. Okay, so that is the next stage. Maybe today we'll have a short, brief overview of matplotlib. So this one, py plot dot scatter, plot dot figure. Okay, So these are certain things that we'll be using in our Python. I'll be explaining to you about this, but in the next video. The video is next, but in today's class itself, we'll try to cope up with that also. So as far as the theoretical part is concerned, today we have understood what is correlation coefficient. We understood the directions for correlation coefficients. We understood the scatter plots. We understood the Pearson coefficient, how to interpret what happens with respect to outliners and so on. And correlation does not simply imply causation. That means that one of the common misunderstandings that we have, or common things that we come across, is that if there is a strong correlation, this is treated as that is the cause of this. It need not be like that. Say, for example, there is an independent variable x, and I am calling this x as the number of cigarettes smoked by a person, and y is the probability that this person suffers from cancer. Okay, even if there is a very strong correlation, this alone need not be the cause of the other. That means that there are chances that a non-smoker can also have cancer. You understood? A strong correlation doesn't mean that this is the cause of the other. Right? Are you clear with my example? You want anything more? I can give you more. Right? Same with the number of hours of study. Doesn't mean that a person who had studied for more number of hours, the number of hours he studied is the reason for his success. That means that there might be people who study very less but score very high in the exams. Less number of hours. You understand? So it means that this is not the reason for X, is not the reason for Y. Reason why Y occurs. Okay. A strong correlation never implies A is the cause for B or X is the cause for Y. Is that clear? That means that a person who studies even 0 hours can get good scores. Clear? Provided he is very attentive in the class. That's enough. In my college days, I found I had many people, including myself, I am also somewhat like that. We don't need to sit and study for hours together. We listen to the teachers' classes or lectures. That's more than enough for success. That's enough, in fact, really. So, these are some review questions. What is the difference between positive and negative correlations? See, these review questions, I would like you to write it as answers in your notes. I wish you write the answers for these review questions in your notes. The reason why is that the basic problem what we face, according to me, you can tell me if I am wrong, because I am also a student. That's why I am telling you all those things. We know certain things, but we do not know how to write it. We are all fed with, especially you people, no? You are fed with question, you are fed with answers. You simply learn it, or you simply by heart it, or you can easily write it directly in your exams. That's what is being done. That is, according to a teacher, it is injustice and wrong. I should not do it to you. I should not give you notes. I should not give you questions. I should not give you answers. Instead, I should give you questions and ask you to write by yourself. Only then you will start thinking and you will start writing. And you will learn how to write. If I ask you all to write some essays or some questions like essays, I'm pretty confident that most of you may not be able to express what you know. You know things, but you don't know how to write it. And how you will improve it? Only by doing it. So these questions are meant for that. You need to write down the difference between positive and negative correlation. And see, everything you do, you will be rewarded with marks in whatever way. If you have written this, you get marks. Okay? So I want all of you to take some initiative and write down these answers. What is the range of Pearson's coefficient minus 1 to 1? Everybody knows, right? All of you know, right? So this is a very simple question, but if you need to answer it for 2 marks, what you will do? Difference between Spearman's and Pearson's coefficient. Okay. Formula, what is it important to check? What is the golden rule for correlation? Calculate the correlation. This one I want everybody to do it. Okay. X is equal to 2y. The question is very simple. The function is x is equal to 2y. The question is available in the, will be available in the YouTube. So you can note it down and write it later on. You can pause it and so on. Now one question which I would like to do is that so this you can do. And one important question I believe I've missed is that one important question that I missed is that one important question I missed is that what is the drawback of Pearson correlation coefficient? What is the major drawback of Pearson's correlation coefficient? This is a discussion time. Actually, I finished my lecture. I finished 2.5 units, which you are expected to get for your first internal exams. And now it's a time I would like to discuss. So, what is the drawback of Pearson's coefficient correlation? Highly sensitive to outliners. Very good. Sensitive to outliners. So these are the basic topics that we have covered today. I'm giving you a summary. And this summary I'm giving you because if you have any clarifications or doubt, we are open to discussions. We can do, we can talk. Okay. So thank you all. Thank you very much. Thank you very much for listening to me. You have anything to ask me, you can ask me. So thank you.